Hello, student. This is the clips that will continue us from what we have on the property of the material, especially those fossil engineering material. We have finished talking about how we select the material for some specific one that we use in our structure. And then we're talking about the steel. We use a lot of steel in the reinforced concrete. And also steel may use in the pre-stressed concrete. And now this part of the lecture, we will talking about the concrete. Okay. And what is the concrete? Typically, concrete is the composite material that we know is from the mix of the Portland cement with the water that produce the cement paste. And then we put the aggregate, which is the sand and crushed stone, into the concrete to produce the concrete cheaper. And then when we construct the concrete, we can separate the construction of the concrete into two types. One, the cast in place, and another one is the precast concrete. Okay, in the cast in place, that means you're going to have a lot of things involved from the starting point. You got to prepare for the formwork. You got to prepare for the formwork. You also got to prepare for the reinforcements. That's over on the sides. And then you're going to put the formwork, okay, into the position. And then you put some reinforcement, okay, for the formwork. And then you close the formwork. And then you got to pour the concrete into the formwork. And then you need to wait for at least 3 days to take the formwork out and go to the further portion of the structure. That's going to take a lot of work and a lot of worker. For the precast, most of the precast concretes nowadays they produce it in the factory, in the concrete plant. That means most of the work involved in a specific closed procedure. That means the precast can be controlled in some specific environment, and then you got a good quality of the precast. Unlike this one, it's work on the inside, so the quality of work may not be that high as that one in the factory. And then after you do the same thing and then you ship it, the same thing as this, okay, but this one you ship it. You ship by 10-wheeler or semi-trailer to the site, and then you just lift it up and put into position. So the cast in place concrete is shown here, and then you may see some construction sites in our SUT area now. Is in the form of cast in place. You can have tower crane here that's going to lift a lot of things when you are moving things around the site. And you have this concrete pump vehicle, so that concrete will be easier to pour into some specific portion of the site. Okay, and the good thing of this cast in place is all the concrete and the reinforcement going to be in unity. It's going to work as a whole. Okay, for the for the precast structure, this one is an example of the mix between the cut in place reinforced concrete and the precast pre-stressed concrete beam. Why you construct the substructure, this portion of this bridge, okay, we call this as the substructure. When you build the substructure, at the same time you may build this superstructure at the same time, superstructure. Okay, and then when the substructure finish, this precast pre-state concrete beam can be shipped and installed in their position, and then they install the slab and do the concrete, it asphalt concrete pavement on the top and install the what's so called the guardrail here. Okay, so most of the time the construction of big structure, they need to have a good plan, such as this bridge. Okay, if this thing go together, it will finish very early while you construct the substructure, which includes the pier, the foundation, the pier, and the cross beam, and then you can cast the pre-stressed concrete and you chip it and you install it. Concrete has the high compressive strength. Okay, that means it can take a lot of compression. However, the concrete have the low tensile strength. That's why we need to put the steel for reinforcement to increase its tensile strength. Okay, we reinforce with steel to increase tensile strength. So reinforced concrete, pre-stressed concrete, is a kind of composite material in which the concrete work with the steel, work with the pre-stressed strength. And there are some big example of large enormous structure in Thailand. The first one, this is the concrete dam. It's the Bhumipol Dam in Tak. It's the biggest dam in Thailand. And this one is used to be the highest building in Thailand is Bayok Tower 2. It's take the length of highest for 20 years. You may have crossed the Western Industrial Link of Bangkok. Okay, you will have the Bhumipol Bridge. Okay, that is the tallest cable stay bridge in Southeast Asia. And there are something else. This is Ananta Samakom, and this is kind of sanitary water in Bangkok, and this is interchange. Okay, most of them built by the concrete because concrete is very durable material. And since the concrete is composed mainly from two parts, okay, we have the cement paste, that is Portland cement. There is some special type of cement, actually for 5 types, and all the Portland cement must follow the Thai industrial standard, and it must follow that. It's legal to do so. And then it's mixed, the Portland cement mixed with water to form the cement paste. Okay, and then we put some filler, which is the aggregate, into the cement paste to reduce the cost of concrete. Okay, so the aggregate must compatible with the cement paste. Okay, they should have very close property. It's the natural material. It's includes with the cost aggregate. When you say its cost aggregate is larger than 4.75 millimeter or 316 inches, you can do by sieving the aggregate to separate between cost aggregate, and those that's smaller than that, we call it fine aggregate. The fine aggregate usually is the sand. Okay, it's a sand. This is a picture of the cut stone, and this is a picture of the sand. You know this thing very well, right? And the concrete is a kind of special thing because it's produced by the limestone. You crush the limestone, you mix it with something, and then you burn it in a high temperature, and then you crush to refine it to very small particle, and then you put the water into it, and then it's kind of have fluidity. Okay, and then you can pour it into the formwork, and then by the hydration process, this liquid cement paste get hardened by what's so called the hydration process. And the hydration process is special. Okay, the concrete can harden even in the water. Okay, so the Portland cement is a kind of hydraulic cement. It can harden after mixing with water, and then there are some chemical reaction inside it that you're going to study in the course of the concrete technology. Okay, technology in the detail. Mainly, after you put the Portland cement with water, you're going to get calcium oxide, silicon oxide, aluminum oxide, and something else. And generally, the concrete will harden after mixed with water within 24 hours. Some special type of concrete can harden within only 3 hours. That is very useful to fix like the pavement of the road, because when you have the bad road surface, you can take that portion out and then reinforce with with steel, and then you pour the concrete, and then that concrete must harden very quick in order you to open the road for the traffic. Okay, and if it's cured, it means you put the humidity, the water for the concrete along the time. Okay, and then the hydration process, you need water to continuously develop the strength of the concrete. So if you kill it properly, the strength and stiffness of the concrete will increase with the time, even though years after you finish the construction of it. But by the way, the concrete must follow the mixed design. You may see the ACI or some coding for the mixed design of the concrete. And also, you will study about the mixed design of the concrete in the concrete technology. In this subject, we're just talking about the introduction of the property of the concrete that we should know before we go further to study the concrete in detail. Okay, in the production of Portland cement, like I tell you, it starts from the mining of the limestone in Thailand. You may have a lot of it in Suranaree. Okay, in Suranaree we have the SCG, we have the TPI, Porin, we have the SCCC. Okay, that is a lot of cement factory there. And then you got the limestone, and then you crush it, make it smaller and smaller, and then you store it, and then you put this into the clay and limestone dryer. That means you need to put the clay with the limestone, and there are some proportional equipment, and then you grinding. Okay, and then you mix with some specific mixture, and then you store it, and you put to the queue. This is going to put a lot of temperature. Okay, and all the mixture will got the reaction inside here. Okay, most of the technology from the SCG and TPI come from Western country, and I heard that the TPI used the system from Germany. And then after it get burning in the kiln, is crushing to the specific size, grinding, crushing to some specific size. So it's going to put into the storage and pack into the bag, or sometimes put into the trailer and move into the construction sites. There are there are 5 types of Portland cement. However, only three are very popular in Thailand. This is the first one. That is the general use. You may use this a lot. Usually, is for example, for the SCG, is have the lace back like this. And the second one that's used quite a lot in some seashore area. that is the Portland cement with sulfate resistant. Okay, that's for the place that has seawater, have soil, salt, like such as in Pimai, such as some area in Loy Ed that have very mm, mm, have very kind of salt inside. Okay, and another one we have the higher strength, in which you may use is to fix some load surface, those kind of thing. And also we have some specific use for the low heat cement that you may use for large bed foundation, or the number two, that's between the moderate surface resistance. That means it's between 1 and 5. Okay, this is the example when the concrete subjected to the seawater. And what is that? If the concrete has what is so the covering, when you design the concrete, usually you have the section of the beam or the column like this, and then if you build this structure in the seashore area, this this covering must be especially larger than the normal one. In a normal structure, such as the column in the building, okay, this covering can be just 24 millimeter to a maximum maybe 50 millimeter is for outside. But if your structure is near the sea or in the sea, this covering should be at least 75 millimeter in order you have the protection of the water won't penetrate, okay, into the steel and get lost. If you have very small, very thin covering, if the water reach the steel can get lost. When steel get lost, steel increase the volume, and then the covering going to get what's so called spalling. This is called the spalling. Spalling. Part of the concrete is just out of its section, and then the reinforcement will have corrosion very quick, and then structure is in harm of deterioration. Okay, concrete can be mixed by two ways, and nowadays the ready mix concrete is very quite popular. And you may know, if you like to use it, you can call the call center of the company, and then after you put the order for your concrete, you may pay the money at 7-Eleven, and then for specific time, the concrete will come into your size. Okay, this kind of concrete is called ready mix. Is from the concrete plant. Okay, and is as very popular since it's very high quality and convenient. You don't have your own concrete mixer. Just concrete will put into this truck, okay, and send into your size. And when you ordered it, your concrete, okay, you got to put the specific concrete strength is maybe like a 240 KSC, 280 KSC, or 320 KSC, or something else. And then you got to specify some specific slump. Okay, slump is the workability. Is measure the workability of the concrete. If have high slump, that means concrete is very wet and it's very easy to pour into the formwork. However, large slump, concrete will have more water. That means concrete with large slump sometimes is have low strength. Okay, and nowadays we have some additive to increase additive. okay, to increase the workability or the slump of the concrete easily. However, anyway, you got to pour the concrete into your formwork within 3 or 4 hours. If not, you got to put some additive, which called the the retardant, to hold the concrete and to delay the hardening of the concrete. Okay, and you also need to set about the largest aggregate size, because it's involved with the distance between the reinforcement. Okay, and everything must follow the Thai industrial standard 213. And this is a picture of the concrete pen. Some of them is in the city. That means it's going to be very convenient. It's going to send to you directly to your sites. And this is the way they pour the concrete, okay, from ready mix. And then you use this called the vibrator. This called the vibrator, okay, to make the concrete. Okay, it's used vibrator used to make concrete compact. Okay, that means when you put the vibrator into the concrete, vibrator will check the concrete and make the air go out of the concrete, and the concrete will get more compact, less void per se. And the bad thing is, don't use this one to dive the concrete. Okay, you need to pour the concrete by moving this, and then you just use the vibrator to compact the concrete properly. We have another way to mix the concrete, is the mix in situ by the worker. Okay, this is only for small work, okay, and in some rural area. So you got to be very careful during your mixes. When I was young, I did a lot of this mixing when I go to build a weir in the far country in the northeastern part of this Thailand. And that is really fun to do so. And some competition make us enjoy working for the people, especially for the rural people. And I did quite a lot of this. The mixer usually is have 1 part of cement with 2 parts of sand and 4 parts of custard. And then you have mix them by your hand. There is some step. Most of the time it start by you mix the sand. Start by the sand with the Portland cement. Okay, Portland cement. And then when everything in a good mix, okay, now you can put some crushed stone, okay, to mix it. And finally, you put the water and mix everything together in the same homogeneous material. Okay, and now we're talking about the precast reinforced concrete or precast pre-stressed concrete. Okay, the reinforced concrete, we use the word RC. The pre-stressed concrete, we use the word PC. Okay, this form of construction is very popular nowadays in Thailand because we lack of worker, and especially nowadays the cost of worker is very expensive. So most of this part of structure, such as the slab, okay, sometimes the beam, okay, they're built in the factory and shipped to the site, and you use the crane to install it. This is the roof panel. Okay, it's high quality also. Now, the concrete has the Portland cement mixed with water, right? And then you got to put aggregate. Like I said, the aggregate is natural material. Mostly it contains the sand and the crushed stone. And the cost of them are cheaper than the Portland cement. That means when you put this one, you're going to reduce the cost of the concrete. However, there are some specific conditions that aggregates must be followed. The aggregate must be strong, okay, durable enough, and have the high compressive strength, which is compatible with the cement paste, okay, and its dimension must be stable and it must be clean. Okay, the aggregate should not have soil or waste or some plant glass inside it. You got to clean the aggregate first before we use it if they're mixed with soil. Okay, and very important is aggregates must have good gradation. Okay, you're going to do the seep analysis, okay, in the concrete technology, and then you need to use the mix design to get a proper gradation. It's going to have the size of aggregate from the big to the small one and distributed properly, have the size distributed properly with small void between them. That means when you have the big aggregate, right, you got to have a small one that's going to stay between the void of the big size aggregate. That's going to minimize the cement paste and reduce the concrete cost. Okay, that's reduce the cement paste because you fill all the part of the void with different size of aggregate. So mixed design is very important. You're gonna follow that. They have some specific like ASTM standards, those kind of things. The water, general, the water also must be clean. Okay, must be clean with the TBDT no more than 2000 ppm, and especially no organic matter, no fish, no plant, no thing in the water. Okay, natural water is good enough, and the tap water is best. Okay, if you stay inside the city, you can use the tap water, okay, in your mixing. But if you go outside, you stay in the rural area, sometimes you got to find the good natural clean water to mix with the concrete. If they have some organic matter into the water, that organic matter will decay in the concrete in the later time and makes the concrete have the low strength. Okay, but I use the mix of concrete for what? For sure, the first one, the concrete needs water for hydration process or hydration reaction, which is the chemical reaction. It needs water because Portland cement is hydraulic cement, hydraulic water. Okay, and then it changes status from the cement jelly, and then it's going to bond the aggregate together when it's hardened. So it's some kind like a glue that's hold all the aggregate together by cement paste. Cement paste helpful, okay, and it also need workability to flow inside all the void and make the concrete more compact. And next, it's also wet the aggregate. It's going to wet aggregate in order that the cement jelly can cover it easier and develop a good bond between aggregate. And during the pouring into the formwork, okay, this water will lubricate the concrete mixer and increase the concrete workability. If there is too small water, okay, your concrete will be hard to compact, even though you use the white better. And nowadays there is some additive, okay, additive that will help you to increase the workability without putting more water into the concrete. Okay, the strength of that concrete with this additive gonna be better than you increase workability by putting more water into the concrete. After you mixing the concrete properly with the proper water, with the proper aggregate, with the proper cement paste, with the proper water cement ratio, and then you pour the concrete into the formwork, and then you compact the concrete with the vibrator. And now, after you left the concrete like for a day, that concrete will start to get hardened. Okay, when concrete get hardened, the cement will use the water, and the amount of water in the concrete reduce. Now is the time for you to curing of the concrete. Okay, concrete curing is a construction process, very important, very important. It's important. Okay, it's important construction process to control and protect. Okay, the water from evaporation from the concrete. Okay, won't let them go away. So the hydration process will have the water to react and get hardened, and also to provide the water to the concrete to ensure continuous hydration process. This hydration process can take like a year. Okay, it's continuous process. It won't stop when it's hardened. It's still there, but it needs water for the reaction to increase the concrete strength and durability. Okay, this is a construction of load surface, and then they spray the water into it, and then they cover it by some specific sheet to hold the water when the sun shine into the concrete surface. Like the water may evaporate, but when it evaporates, it's reach this cover sheet, and then it's still there. It won't go into the air. So we got to consider factor for curing the concrete about the type of cement we use, concrete mixture, required concrete strength, temperature. Over there, too much, too hot, the water will evaporate to the concrete easily. And also, if it have less humidity during curing, you got to put more water to increase the humidity to the concrete. Okay. Usually there are some specific requirement. For example, if you construct the column and the beam, usually they ask you to cure the concrete for at least 7 days. But for myself, you should cure the concrete as long as you can. Okay, during the construction. Okay, this is the graph that shows you the compressive strength. Okay, that is the vertical axis of the concrete of 28 days. The reference of the concrete. Usually, if you go to the STM or the TAS, when you test the concrete, it's required you to cure the concrete for 28 days at the reference. Okay, that is about this today's day. Okay, at 28 days, usually you should have the strength of the concrete of 100% here. That is a must. That is in your contact. That is in your specification. And on this horizontal axis is about the edge of the concrete after you cast it. Okay, after you cast the concrete at some specific point, what you have is the reaction will start, the hydration will start, and then the strength of the concrete will increase rapidly. Okay, within 1 day, and it starts to be hardened, and then again the hydration process won't stop yet. Okay, after 3 days, 7 days, 14 days, the strength can reach of 70%, and then after you finish that, you don't put like 7 days, you won't put any water into the concrete. So the concrete will develop its strength, follow this path due to the no water for the hydration process. It's just in the air entire time. You don't put any water into it. Okay, but if you are really good, you put the water all the way from the start, and then the concrete have water for the hydration process. Okay, it can develop strength to 100% within 28 days. and then the strength still develop when you still putting the water for the concrete, and then the strength can develop as high as 60%, as high as 60% within a year. Okay, and anyway, if during the construction you do some forget about curing the concrete, okay, and you didn't put any water for the concrete for some specific day, let's say for like a week, and then you recall that you got to cure the concrete, okay, the concrete still have the reaction hydration process, and its strength can go up the same as 1 year, okay, and then it can reach as high as 150%. It's up to when you're going to kill it, okay. If you leave it for like 3 months and you start to kill it, it still can go and reach for 145%. Okay, that means the hydration process still there. You need to put enough water into the concrete, and then when you stop putting the water for the concrete, the hydration process stop, okay, and the strength going to be about there all the time. And the bad thing is, don't leave the concrete very dry in the air, okay. Its strength can develop only to about 85% of its desired strength when it's alive for a year, okay. And duration of concrete curing is important, like I said, for the typical reinforced concrete structure from the column, for the beam, and for the wall. You should take it for at least 7 days. Okay, for the floor, for the pavement, it can be 8%. And for special structure, it may take, for example, the road pavement, okay, or the airport pavement. You may take it for 14 years, even though special structure, curved structure. Okay, now what the mechanical property of the material? This material is mixed between water, concrete, cement, and then water and Portland cement, and then you get the cement paste. And then you also put the filler, is the cut stone on the sand into it. Okay, all of this material is the brittle material. However, when it's mixed together and the behavior of the concrete that you get from the compression test is look similar to ductile material. What happens is, when you put the force, okay, into the concrete, what happens is, this force will distribute, okay, to different parts of the concrete. And then what happens is, there are some micro cracks, okay, that occur at the interface between cement paste and the filler, and that micro cracks will distribute, okay, that micro crack will distribute after 50% of stress, okay, 50%. That's micro crack, okay. The small cracks in concrete will continuous go, okay, and the stress the concrete will redistributed into the nearby area. So it's have the crack, but you have your neighbor to taking care of that crack, get the stress distribution. So the crack in the concrete will in the form of progressive cracks, okay. That form of progressive crack is will get this kind of curve, not crack curve like this, okay. That means the failure of the concrete is look like the ductile material more than the brittle material, such as the one that we test for the cast iron, especially in tension. That's brittle failure, okay. Or also the timber, if you put the compression in the direction of the grain parallel to the grain of the wood, it also fail in the brittle type. Anyway, if you put the force in the timber, in the perpendicular, you have a timber, okay, and then it have this one, and you put the force here, okay, it's going to have the ductile behavior also, because the stress distribute, okay, to the wood and to the grain also. The same thing as this one, the stress distribute into the cement paste, when it's cracked, it's distribute into the crushed stone and distribute into the sand, okay. At failure, the concrete tend to, okay, have failure due to the tensile stress. That's in the normal direction. So what we have is, when you put the compression into this, okay, and then the stress will tend it out to split the concrete due to the tensile stress. It's not failed by compression, it failed by the tension. But anyway, since the contact point of the loading head have some specific friction, in which you can reduce by using lamps, but it's still there. But so in some case, there is the frictional force between the loading head and the specimen due to the Poisson effect that prevent the concrete in that area. That's very interesting. So the vertical crack will change into what we have, the inclined crack here. Okay, and this inclined crack is about 50 to 60 degrees, which is different from the cracks in aluminum alloy or in the cast iron, since the surface of this crack is not smooth. Okay, it have the stone and you have the sand that may cause the cone shape, okay, to be have the higher angle compared to those for the cast iron. Okay, for the cast iron, it's going to be here. For the concrete, it's going to be something like this. Okay, if we consider more factors that affect the concrete strength, what they are, from the graph, this graph, you have the compressive strength on the vertical axis, and also you have the water cement ratio. Okay, that means if water cement ratio is high, that is more water. Okay, this is more water, and the water cement ratio is low, this is going to have less water. Okay, what we have is, let us consider the concrete with 0.4 water cement ratio. That means you have 40% of water and 60% of cement. Okay, and you may see the lower water cement ratio, if you consider it's at 28 days, it's going to have the strength of 42 megapascal. If you have 7.5 water cement ratio for 28 days, the strength reduced to about 34. And for 0.6, the strength reduced to about 28 megapascal. And for 0.7, it's reduced for 22. What happened is, when there is too much water, okay, there is less cement. When it's less cement, too much water, compressive strength of the concrete is dropped, because there is no Portland cement to have the hydration process. Okay, that means there is no hydration process, and the compressive strength of the concrete drops due to the less cement reaction to the water. And it's also happened for the other day. And now, if you consider age of the cement. You may see the 28 days, the curve always on the top. 7 days, the curve just getting down. Okay, down. And 3 days, the curve getting lower. That means older, the older concrete, the older concrete or larger concrete age, the compressive strength is up. Because of what? Because concrete have time to have hydration process, or the condition that the concrete have enough water to have the hydration process. So more days, more hydration process, high compressive strength. And the characteristic of the cement, the graph didn't show this. If you have very fine cement, okay, with balanced chemical agent, which is going to be for the new curing machine that we just mentioned when we produce the Portland cement, the compressive strength of the concrete will go up since the hydration process is more complete. Okay, especially in the early age of the concrete. Fine concrete can have more hydration process, quicker hydration process. Okay, that's mean you got to check which company has the most modern Portland cement production process. Most of the modern one will produce very fine Portland cement, and the strength of that concrete can increase rapidly. Next, the moisture content. Okay, like we said before, moisture is good because the concrete needs it for the hydration process. But when concrete wet, the problem is when concrete wet, the compressive strength of the concrete down. Okay, because of the wetness of the material. The better way is when you test the concrete in the lab. When you test, okay, concrete, C-O-N, concrete in the lab, they require you to take the specimen, okay, out of the 28-day curing, and you get to put it for air dye for at least 24 hours before you test. So that's what the specification require you to do that. Okay, so that's going to be the reference. This is going to be 24 hours. Okay, 24. And if you test the specimen earlier, you may get lower compressive strength due to the wetness of the component. Also, the mixed proportion. This is also very important. Okay, and the aggregate. Low cement with improperly mixed proportion. Okay, with the improper aggregate. That's we talking about the gradation. The aggregates must have good gradation that follow the standards such as the ASTM. Okay, if this follow that, it's going to be good. If not, okay, the compressive strength of the concrete also may get lower. Next, we're talking about the modulus of elasticity of the concrete. And if you recall the steel, okay, the steel also have the modulus of elasticity, in which is going to be stress divided by strain. And the steel has what? The steel has constant E for any kind of steel. That means the property, the modulus of elasticity of the steel always constant. But the concrete is not like that. The concrete, the modulus of elasticity of the concrete that show the stiffness. Okay, of the concrete is depend on the strength of the concrete. Okay, they show the stiffness of the concrete under compression is depend on strength. Higher strength, higher stiffness. Okay, because it has ability to resist the force. It has high ability to resist the force. So it has the high ability to resist the deformation. And the unit weight also, with the high unit weight, that means the concrete is compact. The concrete is compact, the concrete is going to have high strength and stiffness. But for the magnitude and duration of the applied force, that's going to reduce the modulus of elasticity. Standard of test for concrete, there are a lot of them. For the Thai, we follow the Thai industrial standard. Okay, this first two is for the Portland cement. This one is Portland cement. Okay, and this is important. That's for the compressive strength of the concrete. So you got to follow this first two. And there are something else. For this one, that's for the concrete aggregate. That is going to be for the sand and the crushed stone. Okay, but mostly it's pretty hard to do this test. We do much. Okay, in our contact, mostly we involve with these two. And also about the concrete admixture. For example, the water retardant. That's going to reduce the amount of water, increase the workability of the concrete without increase the water. Or you may have some kind of air entraining thing agent that's going to make the air in the concrete smaller. This is air entraining agent. This is one of important to make the concrete as compact as possible. Okay, and there is something else that you should study with the STM standard here, which is the basic. That's the TIS, the Thai Industrial Standard developed from. The compressive strength of the concrete, you must follow the STM C31 and the TIS 409. Okay, that include the size of the specimen. Concrete specimen, usually we call it concrete cylinder. Following the STM, it has the diameter of 150 millimeter and have the height over here of 300 millimeter, and the diameter of the concrete cylinder must be larger than the largest aggregate for at least theta. And in our typical construction, the largest aggregate can be 25 to 51 millimeter. That means the diameter of this is 120 millimeter. Okay, and why is 300 millimeter? Because it's going to reduce the friction between the loading head, and the concrete. Okay, the effect of that will cause the concrete fail early. So finally, what is the advantage and disadvantage of using concrete in construction? For sure, the concrete is very economy. Okay, concrete can find easily and very convenient, especially ready mixes concrete. You can just order by putting the order into the company, and then you pay the money at 7-Eleven, and then you can get your concrete. They're going to send you to the sites. The concrete is quite low price, okay, and easy to get, and low maintenance costs, because the concrete is kind of close to the stone. Okay, it won't get lost. It can withstand the weathering, and it also have good character for architectural and engineering work. That means you can pour it into some kind of what so-called the structure such as hyperbolic, paraboloid. Okay, that is a kind of structure in front of Ratchasima University of Technology in the city. Okay, that's very beautiful, structure. It have those kind of very strength, okay, construction into it, and it's kind of a symbol. It's up to how you can do the form work. Okay, so when you do the form work, you can put the reinforcement, and then you can cast the liquid concrete into that formwork, and then after it gets hardened, you can take the formwork off, and then you get the structure. Concrete have high fire resistance, so it's no need for fire-proofing material, unlike the steel that's going to put more cost for the steel structure. And if you mix the concrete with the steel, the concrete also can be the fire-proofing material for the steel also. Concrete have high mass and stiffness. When you build the concrete structure, most of the concrete structure will have the section that's quite big. Okay, you can see it at your home, at your dormitory, at your house. So with the last section, okay, the concrete will have less vibration. Okay, due to this compared to the structure of steel, it can hold vibration easily due to it have high mass and high stiffness. The bad thing, the disadvantage, the concrete have low tensile strength, but anyway, this is not really a disadvantage. You can put the steel, okay, to help the concrete taking the tensile stress, or you can do the pre-stress concrete. You put the stress in the steel first, and then the stress will transfer back to the concrete to resist the force. Okay, and the one of that bad thing is since we do the reinforced concrete and pre-stressed concrete, the design, the analysis and design may be a little bit more complicated than the steel. And also not only for the analysis and design, it also have the detail. Okay, the construction detail, also more complicated than the steel. But anyway, today it's not that hard. You may use the program called BIM, okay, to do that design analysis and construction detailing. It requires formwork and basing, especially the cast in place concrete. That's for sure, because you got to have something to hold the liquid concrete before it gets hardened, and the formwork must be very precise. So it require high quality labor in this construction. Okay, and concrete have low strength to weight ratio. That's going to produce the concrete to have the big section, and when it's big section, it's going to have large dead load, and then it cannot use easily in the long span structure. But we have new choice of pre-stressed concrete nowadays that we can build the concrete structure bigger and bigger nowadays. And the last one, the property of the concrete is time dependent. This is also very important for the pre-stressed concrete. What the time independent behavior is a shrinkage. Shrinkage means the concrete is shrink itself due to the hydration process. Okay, they use the water inside it, and then the cement paste shrink. The size of the real concrete will shrink a little bit, or get smaller a little bit after it hardened. And another thing is the creep. As we may know, the concrete contains the oil inside it, and that's why have the water. If your structure get forces, okay, get forces all the time. Let's put this one. Get forces all the time. the wall going to get closer and closer, right? When it have the force, sorry, it have the force like this. And what happened is when it gets shortened, the water that's in the air void gonna come out and evaporate. When the water evaporate and then you take the force out, this permanent deformation won't get back. This is important when you design the piece-test concrete. Okay, you got to consider the effect of shrinkage and the creep. That's going to reduce the piece-test stress of the concrete, and the effective of the PC can be reduced. Okay, this is the part of the concrete. That's you guys supposed to be good off. You got to understand how to use the concrete. There are some limitations of the concrete. Okay, the best way is we use the concrete with the steel. Is the form of reinforced concrete or in the form of piece-tested concrete. And then the advantage and disadvantage, it will enhance the advantage of both steel and the concrete, and it also reduce the disadvantage of the steel and the concrete. But you got to use it properly. Okay, it's require you to be very understandable, especially for the analysis, especially for the design, and especially for the construction detail. And then when you construct it, you also need to have skillful labor to to build this kind of structure, both on the formwork, both on the reinforcement, and both in the concrete pouring, and also for the concrete clearing. Okay, that is the end of this clips. Bye bye.